Well, good morning and welcome back to the latest Collision Hub webinar. Today we've got Snap-on. We're going to be talking about advanced driver assistance systems and some information from Snap-on on that. So without further ado, I'm going to turn over to Ron Racine to walk us through today's presentation. So good morning. Welcome, Ron.
Thank you, Jason. Good morning, everyone, and welcome to this presentation. Today we're going to cover ADAS and some of the features and things that we're going to be dealing with here in the near future. So I've got a small presentation here. It's about 60 minutes, and we'll walk through that. So what we're going to cover is what is ADAS or ADAS? What function does it perform? Why are these systems needed? What are the main ADAS components? When to perform a calibration or adaptation? Calibration methods, they vary based on the origin of the vehicle, whether it's a German or European vehicle, Asian vehicle, or domestic vehicle. ADAS space requirements, ADAS specialized equipment, ADAS procedures, pre and post scan, ADAS centerline reference, ADAS pull drift and road ground compensation on the electromechanical power steering, and also then we'll go to a conclusion. So the industry partnership, the industry is changing rapidly. Lately we've seen Ford and Amazon invest about $1.3 billion in a startup company called Rivian. They make an electric pickup truck. They also make an electric SUV that resembles a Ford Bronco. And the reason why you see this association is Ford has the mass production capability and Rivian does not. But they have the technology on the electric vehicles, and Ford doesn't necessarily have it. If you look at a Ford Fusion, the electric Ford Fusion actually is a Toyota running gear. So you're going to see more and more of these partnerships occurring, but the industry is changing so rapidly. In the past, we had time to train the technicians. Now it's like a daily thing. You know, you've got to really stay up to speed. So the SAE has defined 5 different categories for autonomous driving vehicle in order to get to the autonomous driving vehicle, which is the ultimate goal for all car manufacturers. So right now the level 0 is no automation. Those are vehicles that are accustomed to driving, where you have to drive the vehicle, you have to accelerate and brake, or in total control. L1 is a driver assistance, so the driver must do all of the driving, but in some you'll get some basic help in some situations. So this vehicle can provide basic helps as automatic emergency braking or lane support, lane keeping, or lane centering, and things like that. Level 2, partial automation. The driver must stay alert even when the vehicle assumes some basic driving tasks, and the vehicle can automatically steer, accelerate, and brake in limited situations. If you look at for example, a Tesla X has a really high level of automation in the driving of that vehicle. Level 3, conditional automation. So the driver must always be ready to take over within a specified period of time when the self-driving systems are enabled to continue. And that happens when you're on let's say you're on a road, and then suddenly you go from asphalt to a snow-covered road or an icy road where the systems can't find the lines, the markings on the ground. Then the system will give control back to the driver. So the driver needs to be somewhat aware of that and be ready to respond and take control of that vehicle. Level 4, high automation. So you can be a passenger. You know, for example, the Google mapping vehicles, and some other taxi providers in the US have vehicles that are self-driving vehicles. So you can be a passenger, but you must be able to also take control of the vehicle in certain conditions where the vehicle may not recognize the environment and not be able to respond. So, and then you have level 5, which is full automation. And full automation, no human driver, no steering wheel. You just get in the vehicle, program your destination. It takes you there. You exit the vehicle leaves. It goes and picks up the next passenger, or it goes and parks itself somewhere. So there are some interesting things about that are coming up. Right now, this year, we are at level 3, conditional automation. So a Tesla, for example, a Model X, when you put it in autopilot, that car will drive itself. So if you set the cruise control for, let's say, 70 miles an hour, and you catch up to a vehicle and he's only doing 60, well, obviously your vehicle is going to slow down to maintain a certain distance and speed of that vehicle ahead of you. If you want to pass the vehicle, all you do is you just hit the turn signal, and the vehicle will execute the pass. Will move in the lane, pass the vehicle, come back in the original lane, and reestablish the speed that you already preset 70 miles an hour. So those vehicles exist. In the heavy duty truck industry, you'll find a lot of autonomous driving vehicles. Actually, you'll find more there than you will in the passenger car at this moment. And also other industries like the mining industries, the farming industry, and also shipping or big ships on the ocean. They're all GPS guided and nobody actually really drives them, but you have to monitor the position. So those systems exist, and if you ever flown in an airplane, that pilot doesn't drive that airplane. That plane just flies itself from point A to point B. It just knows how to do that with all the computers and all the power behind it. The pilot's there to make sure that everything is working correctly. There are no challenges, and if there is a challenge, then you should be able to take over and hopefully land the plane. If we look at ADS, what is ADAS? Well, ADS is a composition of systems. So when you hear, I'm going to have to reset my ADAS system, well, you cannot reset an ADAS. You have to reset the systems that are part of the ADAS group in that vehicle. For example, adaptive cruise control, emergency braking, pedestrian detection, collision avoidance, traffic sign recognition. That's a really cool one. So if you're driving on the road, you get close to a school zone, and there's going to be a sign in your school zone limit 20 miles an hour. If you're not paying attention, the car will drop the speed to 20 miles an hour until it leaves the other side and it leaves the school zones. It's automatic speed control for people who are, let's say, for example, your text message, you want to slide in that last comma because you want to punctuate correctly, right? You're not paying attention to that sign, well, the car will for you. And those systems right now today are really necessary. Lane departure warning, again, your text messaging, you want to put that comma or the exclamation at the end. You're not paying attention and you're actually moving into the oncoming lane. Well, the lane departure warning will warn you of that by shaking the seat, the steering wheel, turning on lights, emitting a chime, things like that to get your attention so you steer back. Lane departure warning, those types of systems can be found on hydraulic powered steering vehicle and also electromechanical power steering vehicle. Park assist, cross traffic alert again, because our peripheral vision sometimes doesn't extend as far as these cameras do. You don't see the car coming and you could have a collision because you did not spot that vehicle who's not going to go to that traffic sign or whatever. So cross traffic alert will monitor that and then will inform the vehicle, hey, there's a potential of impact coming from the right, so stop the vehicle, and it'll apply the brakes and stop the vehicle. As soon as it sees that vehicle in a certain range, it pre-charges the brake system, so it prepares the vehicle for that action. It's faster than a human being. Surround view, well, you know, that's an above view of the vehicle, so you can see what's around the vehicle when you're parallel parking or moving out of the driveway. You can see behind, on the side, front. Blind spot detection, because we won't turn our head when we're moving. You may have a vehicle that's in the blind spot. So this will alert you of that presence. It could be a vehicle, it could be a motorcycle, it could be anything in that area. And it alerts you so you can avoid the maneuver, avoid the collision. Park assist for the rear collision warning, and surround view also for the rear. Also, these systems will work off a long-range radar, short-range or mid-range, and also some of them work with a LiDAR, which is a laser and a camera system. And then you also have cameras like the Subaru WRX, for example, has stereoscopic vision, 2 cameras. The cameras do everything. It's fantastic. Current most common popular systems on the vehicles. This is what the consumer is actually looking for, these systems when they're buying cars now. So they want adaptive cruise control, autonomous emergency braking, blind spot detection. Don't have to turn my head. Oops, pardon me. I gotta move a little box here, so hold on. Forward and rear collision warning systems. That's to reduce the amount of accidents that could have been avoided because you're at a traffic light and the car ahead of you, the light turns green, the car stops, and you're not paying attention and you rear end that vehicle. So this will help to prevent that. Intelligent parking assistance IPA allows you to park either parallel or back the vehicle in between 2 vehicles automatically without using the steering wheel. The car will do it itself. Cross traffic alert. These are systems that will inform you that there is traffic incoming on the side where you're probably not seeing it's out of your peripheral vision, and then it can take action, inform the vehicle, precondition the vehicle, and help you and the vehicle avoid a catastrophic collision. And lane change assist, which is, you know, again, that is more for the autonomous driving vehicles. or like the Tesla, where you do get lane change assist, or you may have lane keeping, which keeps you in the lane centering, which centers the vehicle in the lane, and then the lane departure warning, which simply informs you that you're leaving the lane and that you should steer back into that lane. All right. By September 2022, 20 automakers have committed to make AEB, so automatic emergency braking, a standard feature in their vehicles. So in the model year 2022, 99% of the US market will have autonomous braking built into the vehicle, which is significant because that means that all those vehicles will have at least one radar, but they can have 2 or 3 radars. And for example, if you're in the Northeast and you're driving and it's snowy outside and you lose control or you start sliding, whatever, and the front of the vehicle hits a snowbank, you may not damage the vehicle, but the impact may be severe enough to move the radar off the bracket or move the bracket that's holding the radar, and that will require a calibration. You'll have to go out there and take the snow off. So be careful if you're going to manipulate these radars, especially in cold weather. They have heaters in them, and they get kind of hot after a while. Here's an example of this is an Audi, could be an A7 or an S7, and as you can see here, it's got a mid-range radar in the front. There's a laser scanner. There's a long-range radar. There's another mid-range radar on the right. So it's got 3 radars in the front, 1 laser. There's a camera in the windshield, and that's looking for the activity in front of the vehicle. So it's detecting objects. They'll use a radar to detect the object. They'll use the cameras to define the object because the radar doesn't know what it's looking at. It just knows, hey, the time to impact to the car in front of you is 3 or 4 seconds. So let's take action. Where the camera can actually look and say, oh, that's a car. It's a pedestrian, it's a cyclist, it's a motorcycle. It can define the image where the radar can only detect the distance and the time to impact. So this one has 3 radars in the front, 1 laser, 1 camera, and it has 2 radars in the back and another camera in the back. So it's constantly monitoring, which the driver can't do. When you're driving the vehicle, you're either looking out the windshield, staring at one rear view mirror, side view mirror, left or right, or you got your head turned over your shoulder for the blind spot. You can't be monitoring 360 like these do. And a lot of times people will ask me, well, Ron, would you trust those systems more than you would trust a driver? And the answer is yes, absolutely. I've got a few examples. So things to consider. I get the question, how big of an envelope do these systems work in? Well, normally it's about 492 feet in front of the vehicle, 229 behind the vehicle, and about 147 on each side. So that's the box in which those systems will operate. And what they'll do is detect an oncoming object that might cause an impact. It'll define that object and will inform the vehicle, the precondition itself, to take action, either braking, avoiding, or notifying. For example, pedestrian recognition. When a vehicle sees a pedestrian and it's in the hit zone, so to speak, it'll sound the horn to notify that you're there. It sounds the horn if there's no action that applies. The brake needs to steer the vehicle away from that object if there's no oncoming traffic. It's all done by the vehicle. So we talk about, how do when we calibrate these, do they have to be calibrated on the mechanical geometric center line of the vehicle or on the thrust line of the vehicle? Well, there's different philosophies for that, and it's all based on the origin of the vehicle, whether it's a European vehicle, Asian, or domestic. But the thrust line of the vehicle, so the dynamic direction of the vehicle as it's rolling down the road, and some of you may remember this 1974 Plymouth Duster. They used to dog track so much, the only time they were going straight is when they were turning right. So they were manufactured that way. They just dog track a lot. Well, today dog tracking is unacceptable because the cameras are mounted, the radars are mounted based on the mechanical center line of that vehicle. So if the vehicle is dog tracking, the camera is not actually pointing forward, it's pointing sideways. And a few degrees over a certain distance can make a large difference. For example, a 1/8 of an inch rear toe or a 1/16 of a degree thrust angle over a mile will give you about 28 feet of deviation. So that's over a mile. So these systems are designed for 492 feet. We'd have to figure out how much it is over 492 feet, but it could be completely missing that vehicle, depending on where the vehicle is standing. So examples of ADAS systems and what they do and do to customers, the people that buy these cars, these systems, how do they like those? So blind spot monitoring is one that's very common now. Rear automatic braking, which will stop the vehicle when there's an object behind. It could be a car, it could be a child, it could be an animal, it could be anything, your little pet. So they'll use ultrasonic sensors in the bumper. They'll just sound the chimes. They'll alert the driver to something in that blind spot, which is the rear of the vehicle. Radar object, the radar, so the radar will do object detection. So it'll see that there's something there within a certain range. And normally the radar has a wider field of view, and it can also go further back. So you can detect objects much faster than you would with the ultrasonic sensor. It gives you more time to react. The camera will recognize the object. It'll do the same thing. Sound the chime. We can apply the brakes if the vehicle is equipped with those rear automatic braking systems. Is it wheel alignment dependent? Not really, because you're not moving at excessive speed. So rear camera view or rear view cameras. So 67% of the people who buy those cars really are very satisfied with the rear view camera. You don't have to turn your head. You can just watch the screen. Cross traffic warning. 85% of the people who have those systems say they're very satisfied because it helped them to avoid a crash or a collision with an object. Forward collision, 6 to 9% of the people are very satisfied. Again, it helped them avoid a crash, help them that nightmare of having to bring the vehicle to the body shops. Then rear cross traffic is 85%. Automatic emergency braking, 81% of the consumers or car owners that have those systems are extremely satisfied. Again, avoid a crash. Lane departure warning, 73%, allows them to punctuate correctly as they're texting. Lane keeping assist, 74%. So the lane keeping is slightly different. Lane keeping is only found on the electromechanical power steering and some vehicles that have hybrid electromechanical power steering, some of the BMWs, where you have an actuator on the spool valve that actually moves the spool valve and allows the fluid to flow in the chambers on your cylinder to steer the front wheels. But electromechanical power steering, there's a computer on the steering column that's connected to a motor, and that actually can steer the vehicle and keep it in the lane. So it'll notify you that you're going to be moving into the oncoming lane, but it will steer the vehicle away. 74% of the people really like that. So what that does is the consumer now is satisfied with those systems. The consumer is looking for those systems in the vehicles. It allows the car manufacturers to correctly forecast, how many systems they would like to have in their vehicles, which means that now the system availability increases, the price goes down, and it can make more systems even more available. So AEB and pedestrian detection at work. Watch this video. It's from Austria, and it's a big truck. Now watch this. It's pretty cool.
Flere bedrifter må nå ta mer samfunnsansvar, sier hotellkongen Petter Stordalen. Over 70 000 unge er virksomhet eller utdanning. Fordi det
So that truck is equipped with pedestrian detection and also recognition, automatic emergency braking. So that truck saw the kid, sounded the horn, and applied the brakes from the rearmost axle all the way to that front axle, but has 100% braking capability on every wheel without locking up the wheel and without making that truck pull, which allowed that child the ability to run away from the truck. Now, if you would have froze up in front of the truck, I understand that the video would be different. But nonetheless, that driver did not have enough time. When you look at the frames, he did not have enough time to react, sound the horn, and apply the brakes. The vehicle did that by himself. And yes, I do trust those vehicles with those systems. And so is the consumer. So the advanced driver assist system market was estimated to be $24.24 billion in 2018, and now is projected to reach $91.83 billion in 2025. So the drivers are becoming more dependent on the new technology. You got to have that so you can text message. The cost is being driven down because the manufacturers can forecast more systems, and component accessibility is going up because of the demand, right? It's just that one cycle. It's great. So now we have these vehicles that are all equipped with these ADAS. I call it the ADAS virus. It's infecting cars all over the world. People are buying those cars, and sometimes they have challenges and they need attention. But we have a solution for that. So we're going to look at the solution, and the solution requires space. That's the very first questions you got to ask a customer when he says he wants to do ADAS calibration or ADAS system calibration is, do you have enough space? Is the environment suitable for that type of operation? So here in Conway at the training center, at the J.D. Michaels Training Center, we have a space which is 48 by 24 by 20. And in this space, I can do probably every vehicle: front camera, radar, 360 view, and blind spot. It's a fairly big chunk of space, right? And right now, when you look at this picture, you can see the doors open, and I've got some light shining on the targets there. And the top part of the target is, there's some contrast on the target. That's a big no-no. This would not work. So the environment is very important. So you have to have ambient light. So when you close the door, you can see now I've got really nice ambient light, and the targets have no reflections on them. And this is the ideal environment to do a calibration right the first time and not have to repeat it. Now, you have to remember, you may have to do the calibration 2 or 3 times on some vehicles. You may not be successful the first time, and that's okay. It's just the way it works. So here's an example of ambient light and homogeneous light. So you know, if the contrast on the left is too excessive, that would not work well. The one on the right is the ideal one. We painted the ceiling black, we painted all the doors black, so we wouldn't have too much refraction or reflection, and that works really well in this environment. Also, you're going to need a lot of space. So, for example, this is the space required in front of the vehicle by manufacturer, from Honda all the way down to Mercedes-Benz. If you look at Honda and Acura, for the front camera, you need 19.6 feet in front of the front axle. For the Nissan and the Mazda, you're going to need about 16.04. So if you've got 19.6 feet in front of the car, you're good to go. You can cover all of those vehicles. This is an example. It's a 2019 CRV. So the CRV is 181 inches long, so 15 feet. Target placement is 6,000 millimeters in front of the center of the front axle, which is close to 20 feet. It's 19.86, so we'll just call it 20 feet. You're going to need a little bit of distance behind the vehicle because you got to get in there to set your laser and to find that center line, the rear center point, to establish the center line. So the overall distance you're going to need for this car is 38 feet. And if you have this distance, then you can do all, or I would say all vehicles with camera and radars, not BSM, blind spot, and AVM. That's different. Here's an example. This is Toyota. Toyota says you can do it in a smaller bay, 22.76 feet long, which would be the equivalent of a standard alignment bay. However, the vehicle cannot be on an alignment rack that's 10.5 inches above ground. It has to be flush mounted. So the wheels of the vehicle need to reside on the same plane as your fixture. Otherwise, your height will be incorrect. Rookie mistake, we get a lot of those. Ford AVM, these are different. Now Ford is a slightly different deal. So for some other SUVs and pickup trucks, you need these mats. The mats are 36.1 feet long, they're 5 feet wide. The vehicle's 80 inches wide, plus you need another 6 inch on each side to lay those mats. So you're looking at an area of about 40 feet long by 17, 18 feet wide to be able to do the blind spot and also the above view or the 360 view on some of these Ford. You can buy these. They're available for $1,795, and your scan tool may give you the ability to go in there and trigger the calibration. So this is not a drive cycle. It's a static calibration. It has to be done in shop. It needs to be clean. You don't want to get those targets dirty. You got to roll them up when you're done. You don't want to roll all the dirt with the targets either. So it requires a specialized area to do this correctly. Mitsubishi AVM, they use the same similar target as Ford. Just go up against the wheel, and if I see my mouse there. There's markings. There are markings on the target to allow you to line it with the center of the wheel. And then you use your scan tool. You invoke the calibration procedure, and then look at these lines and calibrate itself. Remember, the targets don't calibrate the vehicle. The scan tool doesn't calibrate the vehicle. The car calibrates itself. Mercedes, yeah, they're always different. So Mercedes, they have all of these targets that go around the vehicle, so you need a really large space. So about 17 feet wide, you know, about 38, 40 feet long. As you can see, that building there is all white and nice and clean. You got to lay those targets down, connect the scan tool to it, invoke the calibration, and wait for the vehicle to take all these pictures, stitch them together, and determine its position in that environment. Nissan. So Nissan, they want you to park the vehicle inside the building on a nice clean floor. Then you got to do all this geometry and lay these lines down. So you need a string and a plumb bob to find the front center point. Then you find the rear center point. You pull a line down the middle of the vehicle. Then you do some geometry and you mark the floor where you need to put the calibration fixtures or the targets. So this takes about an hour to do. Got to have a nice clean floor. Can't be wet. Tape won't stick. It's kind of ironic, isn't it? Advanced driver assist systems, where we're going to use a string and a plumb bob, more strings and tape to calibrate those systems. Just saying. Here's an example. This is a Hyundai. You can see there on the left and right, they have side-facing radars. So they're moving away from those ultrasonic sensors because the ultrasonic sensors have a very short reach. The radars have a longer reach and they have a wider view on both the horizontal and vertical axis. So you get a bigger picture of what's around that vehicle. So again, if you back this up on a snowbank, you know, you may not damage the vehicle, but if that radar is compressed by the bumper, they didn't bracket, then the radar is on calibration. Some vehicles like Fords, they have the BSM or the blind spot monitoring built in the rear tail lights. So when you remove a tail light, you're going to have to reset that. You're going to need those long targets on the floor. I also get these questions a lot of time. What about the levelness and flatness of the floor? If you're in a standard constructed building, so if it's been built by a contractor, they have numbers for floor levelness and floor flatness. And normally the floor will be flat enough and level enough for you to accomplish that calibration. If it's a Volkswagen, an Audi, a Lamborghini, a Porsche, any of the VAG products, they have to be done on an alignment rack because that is a level surface. Here are a couple of examples of conditions that will impede on your calibration. So this is the ideal right here. You can see the wheels of the vehicles are resting on the same plane as the fixture. And when we set the fixture height for the target, there's a ruler on the back of the fixture and you loosen a thumb screw and you lower the fixture, the ruler until it touches the ground. So you're actually measuring from where the wheels are touching the ground for the camera height. If you have this situation where you're on two different slabs and one slab is leaning downward, then when you level a fixture, you're going to have calibration challenges. The target height won't be correct. Or this type of situation where the slab actually points upward, that's the problem. You see these also where there's two different heights. So you park the vehicle on one slab, I've got a big enough area, but there's two different heights. Now what some guys will do is they'll build a platform and they'll mount the calibration fixture on that platform. That is acceptable as long as you remember to do that. And you're going to have to move it, right, from the bumper all the way to 6,000 millimeters. This is a different situation where now the car is lower, and then again, you can measure the height and subtract that from the height. You measure this in millimeters, you can subtract. So there are ways around this situation, but you got to remember to do it. That's the problem. And this is the one that we see the most is the guy buys a system, calibration system, and he's trying to calibrate a vehicle and his bay is not long enough. So he parks the vehicle on the approach to the shop and he sets the fixture inside the shop. And now we're on two different planes, there's an angle, and it's not working really well for him. Space is very important for ADAS. Those of you who have done Mercedes Distronic systems back in the 1990s, we needed like 48 feet in front of the vehicle, and you would have to do it several times before you get it right. It had to be a really flat surface. That was back in the 90s, right? So the longest distance between the vehicle and target board is 6,000 millimeters at this today, at this point in time. Those would be the Hondas and Acuras. So if you have a 1 degree floor incline over 20 feet, it'll give you about 342 thousandths of an inch difference in height. Nothing to worry about. That's okay. If you have 10 degrees, that's 3 inches. Now there's something to worry about right there. So normally, if the building has been constructed by contractors and it's a commercial building, that floor, the slabs will be flat and level and will be acceptable. You can always measure that using a self-leveling laser. Take a measure where the wheel is, extend it 20 feet out, then measure the height at 20 feet. Why do we need these systems? This is why. The National Safety Council reports that cell phone usage while driving leads to 1.6 million crashes each year. So nearly 390,000 injuries occur each year from accidents caused by texting while driving. So one out of every 4 car accident in the United States is caused by texting and driving. This is why the customers are looking for lane keeping systems, automatic, front automatic braking, autonomous cruise control, where the vehicle can do most of the driving while they're doing other things. In some states and cities, they have ordinances that will say, hey, no texting while driving. Well, the problem here is if you're driving and texting, you may not see the sign. Right? So anyway, you may get caught. Other countries like Australia, they have cameras, they take pictures. In this case, you can see the drivers on the left, passengers on the right, the driver's text messaging, and the passenger is actually steering the vehicle. So now we have 2 brains driving one vehicle. One brain is controlling the accelerator and brake, and the other brain is controlling the direction of the vehicle. So in case of an emergency, they may not be able to connect the 2 brains together and do the right things to avoid a collision or avoid running off the road or things like that. So that's why when they ask me if I trust these systems more than I would trust the driver, and I answer yes, this is one of the reasons. The big truck is another reason. So there are several reasons why these systems are required today. What are the main components? We'll go over this briefly. So we have cameras in the front. They can be pantoscopic cameras. Those are single lens that pan digitally. Then you have stereoscopic cameras that you'll find like in the Subaru WRX. There's 2 cameras. Some of the BMWs now have 2 cameras. Normally they're mounted on the roof line on the front behind the windshield. They could be at the rear also. You'll have radars and lidars. So a lidar is a laser camera. Normally on the radars, they'll use a Bosch LR4, which is a 3-rod, 77 gigahertz, 450 feet distance radar. Those will be found in the front or rear. They could be behind the grille, behind the bumper, and there's 3 different flavors. You have short range, mid range, and long range. And here's the deal. If you have autonomous cruise control, the autonomous cruise control on most cars will only operate from 30 miles an hour to 90 miles an hour. That's the operating range. So when you get down to 30 miles an hour, the ACC gives the control back to the driver. So with autonomous emergency braking or automatic emergency braking, the ACC, the autonomous cruise control, will give the control back to that other radar, which is a short range radar, and it will apply the brakes and stop the vehicle. So pre-charge the system, apply the brakes, and stop the vehicle on behalf of the driver because the driver is busy doing other things. We're not paying attention. Or maybe he's ill and can't drive. That can also be a cause. Ultrasonic transmitters, those are, you'll find them in the front rear bumpers, those little round pucks. Those are probably, they're going away right now in the newer cars. They're dropping those in favor of radars. Steering angle sensors, they've been around since 1992. Ford Crown Vic with air suspension had steering angle sensors to inform the computer the driver is turning right. So jack the position on the left side and lower the position on the air pressure in the air bellows on the right side. It was to trim the attitude of the vehicle when you accelerated and turned. So it really didn't do anything to intervene on behalf of the driver, but it did change the attitude of the vehicle. Made great cop cars. Wheel speed sensors, they've been around since probably around 1971, if I recall correctly, on Chrysler Imperial with ABS system, and now they're on every vehicle. You cannot find a vehicle that doesn't have speed sensors. So they have them in the front, the back. Some have 4, some have 3. It depends on whether it's an independent four-wheel vehicle or if it's a solid rear axle. The majority will have 4 with electronic stability control because you've got to control all 4 wheels, and these will report the wheel speed to the onboard computer. That onboard computer will share that wheel speed information with various host controllers on the car that will control things like automatic emergency braking. So for example, if you go to a bigger wheel and a bigger tire, your road speed will be different. So the time to impact calculation by that radar will be based on the road speed and the vehicle in front of you. So it is not a good idea to change the overall diameter of a tire on a vehicle that has autonomous emergency braking. So modifications are going to kind of go away in the future because those vehicles now are homologated, which means the manufacturer made the vehicle this way with these sensors and these tire sizes and tire pressure and wheel sizes, and it'll be tough to change those components. Here's an example of a camera for those of you who are not familiar. So this camera is mounted behind the windshield. There's a little hood there behind the windshield, and you have a camera right next to it. You'll have some rain sensors. These cameras will control lane departure warning, lane keeping, automatic headlight, I-beam activation, dimming, and other functions also as well. Front-facing serial cameras on the Subaru, automatic emergency braking, and that cruise control, lane departure warning, lane keeping, pedestrian recognition. All this stuff is done, even traffic sign recognition is done by the cameras, right? But the cameras can detect the object, define the object distance as well. Here's an example. This is a Tesla camera, and you can see what the camera is actually spotting. So you can see the lines, you can see the curves, the signs, the vehicles. There's a lot going on that this camera can see, and it reports all this information to the main, the IPMA, so the main host controller for the camera, and those informations are shared with other controllers to either make decisions on behalf of the driver, to intervene, to minimize or to maybe mitigate a collision, or even avoid a collision in some cases. So the cameras have really come a long way since 2005. So they are faster, more reliable, they see more things and recognize more objects, and just a bit better camera. Rear side facing radars, again, we'll talk about that. So these have a range up to 50 meters, 164 feet, and they can detect vehicles crossing to the left or right behind the drivers. Also other objects like cyclists, motorcyclists, up in the Northeast, snowmobiles, whatever's on the road. Ultrasonic sensors, those little pucks, those are going away, but they really have a short distance, 2 to 2.5 millimeters, and that's about it. And they're not really reliable. If there's dirt on it, it may not work. For those of you who have pickup trucks with those in the bumpers, if you don't have a factory installed trailer package, when you hook your trailer up, well, they see the trailer and they start to buzz. Steering angle sensors, they've been around since 1992. Some of them have to be reset, some of them don't. The majority right now are all adaptive. So as soon as you start the car and you start driving, you do not adaptation on that drive. For example, if you're in Arizona and you're in the valley and it's 80 degrees, you drive up to Flagstaff and then you get snowed up there. So the conditions or road conditions will change. The activity on the steering wheel will change. You'll be steering more left and right, more steering input. So the computer will reset itself and say, hey, this is a plausible range. There are no zero reset. That just simply does not exist. So it's a plausible range. It'll say, okay, for now, in this range, don't trigger any system. Anything above that, we'll start making decisions on whether we should slow the vehicle down, apply the brakes, or whatever needs to be done. A few historical dates to refresh our memory. 1992, Mitsubishi were the first to offer a LiDAR-based detection system. Toyota offered a laser adaptive also in 97. 99, Mercedes introduced the Distronic system. Jaguar radar base. Nissan laser, and you see the trend here. So the Asians were going more towards the laser and radar, the LiDAR, but the Germans were going more towards the radar. BMW radar active cruise control, that's the year 2000, so that's 20 years old. Everybody's going the hog wild on this ADAS stuff. It's been around for quite some time. The Lexus division, so first they brought laser ACC in the US market. Toyota, with their ACC, they added brake control. Then in 2001, Infiniti, the laser intelligent control system. Renault, adaptive cruise control. Lancia, radar. So the Italians were going more towards radar also. Volkswagen. So that big target you see in most of the ADAS advertising that looks like a large domino, that is a Volkswagen or VAS target. It was first printed in 2003. That's 17 years ago. So when you're talking to a Volkswagen technician, he knows all about this. He's done it. He had to live the hell what they say. And he knows about the targets, he knows about the calibration, he knows how to prepare the vehicle, precondition the vehicle. Those people, they know they've been working with these systems for quite some time. 2003 is when we had the first North American or domestic vehicle with a cruise control, and that was the Cadillac ACC, which was a Bosch system sold under the TRW. So it was a partnership. Most significant ADAS systems. So these systems right now, this is level 1. So integration, driver assist, but we're going to take it to step number 2 here in a few years. We're going to have V2V, so vehicle-to-vehicle communication with cellular phones and things like that in the car. So if you're so let's say you're driving ahead of me and you're traveling at 60 miles an hour and there's a catastrophic event in front of you and you have to apply the brakes really, really hard. When you apply the brakes, or it may not apply the brakes, but if the system applies itself automatically with AEB, when that one hits the brakes, it'll inform the vehicle behind you that you're braking and that vehicle will start to brake. So in this case, you don't have to wait for a driver reaction. You get a communication from the vehicle ahead and your vehicle will start to slow down as well. So these are things they're going to do with the V2V. It's better control, accident, collision mitigation, collision avoidance, and driver assistance. Also, in the case the driver is incapable of driving the vehicle for whatever reason. So these systems are predictive systems. So they actually measure distances. They know there's a vehicle ahead of you. They know the speed and also the closing rate. And the closing rate for when you look at these computers, they think of it as time to impact. And normally there's 4 phases. So the first phase, the computer will say, hey, I think you're closing in too quickly. I'm going to warn you, so I'm going to sound a chime and put a little display there on your driver information center. The second phase is I'm going to sound a little chime. I might shake the steering wheel and put another piece of information notifying you that you should slow down or you're going to hit that object in front of you. The third phase is, okay, I'm going to start braking. So now in phase 2, it pre-charges the brake system. So the brake pressure is at the correct pressure to slow the vehicle down in the respective amount of time so you don't hit that object in front of you. In phase 3, it starts to apply the brakes. And in phase 4, if the driver doesn't touch the brake pedal, it brings that vehicle to a complete stop. And that could work both ways. It could be that vehicle in front of you sending a signal to your car that you're too close and you need to slow down and maintain the distance. So when should we calibrate or adapt or adaptation to be performed? So when we should calibrate, I call it adaptation. If you're doing a dynamic system, you're going to drive the vehicle. It's more of an adaptation than a calibration. So after collision repair, bumper repair, wheel alignment, customer complaint, system failure, windshield replacement, suspension repair, sensor replacement, or if you change the tire sizes, they all need to be recalibrated. That's your lasers, your cameras, and your radars. So for example, if you're at Volkswagen or Audi, and you get an S7 in with 3 radars and a camera, you're going to be calibrating all 4 of them. And trust me, they charge for all 4 of them, plus the alignment. Or when you have a problem like this and you get a message in the information system that says speed limit, assist inoperable. Well, it all depends where you're at. So if you're driving in a snowstorm and that the radar, the laser gets all plugged up, that message will pop up. Or there might be a problem with that system. There might be a malfunction. So when you get these messages, the vehicle has to go to the repair facility. You do a pre-scan, you pull the code, determine the source, the root cause of that. Why is this system, this code in there? And then you follow the repair procedure, then the calibration procedure to overcome that obstacle. Side-facing radars, again, they get damaged a lot. Minor collisions that may not show any damage or just a little scratch, for example, on the bumper, that would require calibration. Or the unit hasn't been connected. This came back from a body shop and it had not been connected. So we understand in a body shop you have several people working on the vehicle and somebody just forgot to connect it, and then you get the malfunction error message. Or this one here where the customer complaint here, in this case was that the blind spot or the cross traffic would only pop up when the car was almost next to the vehicle. Well, the radar was installed incorrectly. Unfortunately, this one is like an equilateral triangle for the bolt pattern. It can be put in any position. So the position on the left is incorrect. The position on the right is the correct position. And there is no label on that radar that says this side up. However, there is a similar radar on the opposite side. FCA gateway. This is a challenge for most people now, depending on what type of scan tool you have. In some cases, to get to the calibration, you have to take the center part, the center console out and pull components out so you can access a connector behind the controller. And you plug a 12 pin and 8 pin cable, plug that into your scan tool, and then you can scan. Or if you have Snap-on scan tool, you just go to the Altus drive, you register with FCA, and it'll unlock your scan tool, and you can do it through the OBD, so you don't have to tear all that apart. You'll save an hour. Incorrectly repaired vehicle. So this one here, if you look at the radar, this is a Volkswagen, so that's a Bosch LR4 radar. And you can see the upper left ear on the mount is broken off, and it's been attached using a zip tie. Classic repair. So now we have an individual attempting to calibrate this, and he's getting a calibration failure and blaming the equipment, the calibration equipment, not being able to calibrate that. So we have to go back in, pull the emblem, and have a look, and then we saw that that was broken. It hadn't been fixed correctly, hadn't been repaired, hadn't been fixed but not repaired, and that was a problem. So we put a new radar, recalibrated, everything's fine. Here's another example, radar on a Honda Accord. So there's a panel in front of that radar, and you take the panel off, and the radar is behind it. That one had been put on there with double-sided tape, and it wasn't really high-quality double-sided tape because it fell, and the radar was laying down and couldn't calibrate. So you always have to look at the work to make sure the work has been done right and things are in the correct position. I know from the collision industry on the mounts for the radars, they have specific control points that can be precisely measured with the equipment that you have, and that has to be done. Make sure the radar is in the right location and not mounted with double-sided tape. Accuracy is very, very important, right, when you're doing these types of calibration. You know, my question was always has been, what is the camera doing when it's calibrated? I know what the radar is doing, but what is the camera doing? And why can I not calibrate a camera outside when I'm driving the vehicle, the camera's in service, and it's working out in the big sunlight, but I can't calibrate it out in the sunlight? And the reason is very simple. On a camera, when you place it in calibration mode, all the filters go away. So it's looking for a very specific pattern in a very specific location. So distance from the vehicle, a height from the vehicle, and also a side-to-side position. So it's looking for that pattern. So it's important to have target boards that are rigid, that don't flex, do not bow, or do not cave in, because that changes the shape of that target. It goes from being flat, non-distorted, to a pin cushion or a barrel, and the cameras may not recognize it or maybe fail the calibration because it doesn't recognize the target as being the correct target. And this is what it would look like. So in the middle there, that's no distortion. That would be the ideal target from the camera. And on the left side, you have a pin cushion. So that could be a target that's made out of like a foam board or some of that cardboard target that can distort. Our targets, the one we've tested them in an environmental chambers all the way down to -40 to 110 degrees for flex. So to ensure that they do not change when they're in a regular work environment. And on the right there, you can see it's a barrel shape. So obviously when the camera sees this, it's totally distorted and it can't calibrate, and you get a calibration failure message. Or you go on these websites or group sites on Facebook, and they have all these kinds of, has anybody ever done this type of calibration? And have you ever encountered this type of problem where it won't calibrate? Well, what's the target? We have to go back to the basics. You know, what does the target look like? How about the distance, the height? What's the environment? How about the lighting inside the building? Do you have contrasting components behind the target? You know, something as simple as a window with the sun shining through it behind the targets compared to the wall, that's contrast, and it may not allow you to calibrate. Distinct calibration and adaptation methods, there are 2 of them. So we have to look at the car manufacturer. So there's 3 different philosophies. So the German vehicles, the majority are static. They require an alignment rack for a level surface. They require a wheel alignment before you do that. And they require target boards for lane departure warning and ACC, and they require a scan tool. And also, in addition to that, the fixture that holds the target board has an additional camera mounted on it, so you can position a target board on the thrust line of the vehicle, because the German manufacturers like Volkswagen do not trust the technician on finding the mechanical geometric center line of the vehicle. But they can trust the aligner to find the thrust line and position that board on that thrust line. Normally, after your alignment, your thrust line should coincide with your geometric center line, and then that's where they want the board to be mounted. Very different. The Asian vehicles, some are static, some are dynamic, some are both. For Hondas, for example, in the scan tool on the Honda, it'll say static and dynamic. If you click on dynamic, it'll make you do a static first, then have you go out for a drive to complete the dynamic. So they'll recommend or suggest a wheel alignment. For example, Honda and Hyundai will say, well, you know, look at the vehicle, and if you think it needs a wheel alignment, you should do the wheel alignment before you do the calibration. Good standard practice, best practice, always align the vehicle before you do a calibration. So all four wheels will be pointing in the same direction as the camera. In addition, always do a pre-scan. And if there are codes in the computers, fix those first before you continue. If you have a wheel speed sensor, you may not be able to achieve a calibration on certain systems that require that information. Right? They do not, the Asian vehicles for the most part do not require an alignment rack. They do require targets, and they do require a scan tool to invoke the calibration procedure. Domestic vehicles, the majority are dynamic for ACC and lane departure warning. Blind spots in 360 or above view monitoring are all static. And that's like that Ford, where you need those big targets, the big mats. And then they'll require a drive cycle. And the drive cycles will take anything between 5 minutes to 1 hour. It all depends if you're in a target-rich environment. So for example, the Ford Fusion lane departure warning system, 250 targets or 250 variation of things it needs to see before it calibrates. So in the dash, in the driver information system, it'll say LDW not calibrated, and you drive the vehicle, and when it's calibrated, it'll say calibrate. The only thing is you don't have a report. So if you connect a scan tool, you can watch the scan tool, and the scan tool will tell you either completed or not calibrated, and when it's done, it'll say completed and calibrated, then you can go click, save that, you can beam the information up to a cloud drive somewhere, and you have a permanent documented record of that event. So static calibration will require targets. There's a bunch of different targets because there's no protocol right now in the industry on what type of targets you should be using. They'll require tools and hardwares and a scan tool. And you'll need space. You need a lot of space. So standard shop bay normally isn't long enough to do all of the vehicles. You'll be able to do some vehicles, but not all of them. You can do all of the dynamics, but static, you're going to need more space. You're going to need a scan tool, whether it's this one or any other scan tool. You need a scan tool capable of connecting to the vehicle and talking with those host controllers inside that vehicle so you get feedback from the vehicle, and you can also invoke calibration procedures and complete the task. We'll pass that one. Dynamic calibration, dynamic is slightly different. So dynamic, you'll have to invoke calibration. So you'll need a scan tool to tell the computer, please, go into the calibration mode. We're going to go on a drive cycle, do your observations. Whenever you determine the position of the vehicle based on your observations and deemed it calibrated, it'll give you a comment back. For this, you also need a labor guide because they are different. For example, on the Ford, they'll allow up to 0.7 to reprogram an IPMA camera, and then 1.7 hours to go and calibrate it, because you're going to have to go drive that vehicle, and you may not be successful the first time. And you're going to need a scan tool. Scan tool is a great tool because it gives you feedback. When the computer's done, it'll tell you it's done, and you'll see it in the scan tool. Initialization, you may have to program a vehicle, so you may need a pass-through to do that, a J2534 pass-through, to be able to reprogram that new component you put in there. And some manufacturers, the program is in the component. You just have to connect to the component, and then you have to initialize the component so that the main host controller can look at that and say, yes, that's a camera that works with this vehicle. If this is coming from a junkyard or the serial number matched, it's a matched serial number, let's go ahead, calibrate it, go out for a drive, whatever, and you're good to go. So these take a little more time, so you need a labor guide. You can't do a flat rate on these. Trust me, you're going to go out of business if you're doing a flat rate. Confirmation example, so before the drive cycle, you see here it says not learned, and after the drive cycle it says learned. That's the onboard computer reporting to the scan tool that it has learned the procedure and the vehicle is calibrated. That you save as a permanent record of that event, just in case you might need it later on. So quick recap, static calibration requires space, specialized equipment, a drive cycle to confirm in some cases. Toyotas are the prime example. Dynamic calibration requires a drive cycle, a scan tool, in some cases specialized tools. For example, on the Ford Taurus, if you're going to do a front radar, you're going to need specialized tools in the form of a protractor and a level. You're going to need a qualified technician. Now, this guy needs to be trained because, you know, there's a big liability factor involved with doing these procedures. This is not like putting air in a tire, which, you know, could contain a certain liability factor there too. You need a dedicated area for this and a labor guide. You might need some books that'll give you information on ADAS coverage by manufacturer, make, model, year, and submodels, what is covered, what is not covered. This is an example. This is a book that comes from Snap-on. So if it's in this book, the scan tool covers that activity, whether it's for steering angle sensor reset, stability control, ADAS, or TPMS information. If it's in the book, it's in the scan tool. Wheel aligners now, so the John B and also the Hoffman brand of wheel aligners are indexed, so the databases are indexed for ADAS. So if there are targets available for that vehicle, you'll have a notification that will pop up after you do your vehicle selection. So you click on the little I, the information button, and that will take you to the book. And then the book will say here, for this Toyota, for example, 2017 Toyota Camry, front calibration camera target 7 measurements. Use the Toyota FC03 target. There's your distance. So the target stand needs to be 2,129 millimeters in front of the center of the front axle. The target needs to be 1,350 millimeters from the ground. See the B dimension? And the spacing on the target needs to be 160 millimeters from the center line. So you can set that up, put your target, connect your scan tool. Obviously, it will already be, it's going to be already connected because you did a pre-scan. You go to the scan tool, you hit the button, you invoke the calibration. On this Toyota, for example, this is a 3 position. So you'll start in the middle, and when it gets the target in the middle, the system will inform you to move to the left. It'll give you the position for the left, and then move to the right. You move the target to the right, you hit the scan tool, and you calibrate all 3 positions, and you're done. This setup with the easy ADAS system takes about 10 minutes. The factory setup with the plumb bobs and the strings, probably about an hour for somebody that's really good at it. Hour and a half if you're just starting. The geometry is very involved. If it's a radar, we'll tell you which radar target to use because there's 3 different reflectors. There's a 1, 2, and 3. There are different sizes for different radars. We'll also give you the dimensions where to set the radar to switch from the front bumper. Notice not from the center of the axle, but from the bumper, and it will give you the height, 771 millimeters from the ground. Mercedes-Benz rear camera calibration. When you select that vehicle in the aligner, it will tell you use these targets. MB, Mercedes-Benz RC rear camera 01. Here's your target distance, 1,000 millimeters. Those go on the floor behind the vehicle. So you don't need a target stand, but you need a nice clean floor and no one walking in that area to lower the targets. There's also an app available for Snap-on products, which is the Easy ADAS app, and this app contains all the information. So when you select a vehicle, it'll show you which target to use. It'll give you some information on where the target needs to be positioned. So if it's 4,000 millimeters, that's 12 feet in front of the vehicle, right? You'll know if you've got enough room to do it. And then you have information like unload the vehicle, how to precondition the vehicle for the calibration. Remember, if the vehicle is loaded, the ride height will be different. The target will still be positioned for an unloaded vehicle. So you have to unload the vehicle. If it's a BMW, you may have to load the vehicle or load in. If the manufacturer in his procedure says you should have a full tank of gas, you should have a full tank of gas. You should make sure you have a full tank of gas. And here's why. Some of the manufacturers are actually repeating the fuel sender information before when you're calibrating. And if it's not full, because you can put weight in the rear, right? So I don't have a full tank of gas. I'm going to put 70 pounds in the trunk. Well, the fuel sender won't change position and the calibration may not work. Follow the procedures step by step. Also, there's videos in this little app that show you step by step how to position, how to find the front center point, the rear center point, establish the mechanical geometric center line of the vehicle, where to position the stands, the height. So there's different procedures for different makes, model, and year, and they're all included in this beautiful little app, Easy ADAS app. Oh, I just went too quickly here. So another piece of information, some manufacturers require additional information to be entered in the scan tool. So as you're going through the process and you set everything up, they may require to input the distance from the ground to the target. And those numbers are included in this app. So you don't have to go to your information system. You download the app on your Android or your iPhone. You have the information. You just enter that information in the scan tool. It makes calculations for you to determine the proper height or the CH value or DH value of that vehicle, so you don't have to do it. And then when that's done, you're ready to calibrate. These are rookie mistakes that have been made in the field right now by people who are doing mobile calibrations where they missed this part. So quickly, because I'm running over here. So this is an example of an OEM procedure using a plumb bob and a string. And you can see all the geometry there, right? That's why I say it takes about an hour and a half to do all of this because you have to read, you have to measure, and you have to position, and you have to mark the floor for these targets for every vehicle. It was very lengthy. The Easy ADAS will cut about an hour of your time on this setup. All right. So again, it's critical that we set the target based on the mechanical geometric center line of that vehicle when required by the manufacturer, or on the truss line of the vehicle when required by the manufacturer, mostly German manufacturers. Follow the OEM procedures and you will be successful. This system, for example, is a rear wheel reference only. Some may think it's a truss line, but you're not compensating the rear targets. It's so that therefore you do not know where the truss line is. So the orientation of that laser could be incorrect based on the run out of that wheel. So if the wheel is not perfectly perpendicular to the spin axis, then the laser will reflect that and it'll change the center of your center line. And it would look like this. So best practices, always follow OEM procedures, step by step. All right. So I'm running over here, so let me, I'm gonna have to go to the end. Jason, are you still on?
You bet I am.
So how much more time do I have here?
You're good. You're good, my friend. Just the people have been interested in this stuff, so have at it.
Okay. So quick, just a quick piece of information. Always use a scan. When you bring a vehicle in the shop, never perform any operation on the vehicle until you pre-scan that vehicle. So connect the scan tool, do a pre-scan. If you have a snap-on scan tool, you can go, it gets a code scan, pre-scan. It's going to go in there and interrogate every host controller on that vehicle. So if it's a BMW, you may have 92 controllers. If it's a Ford F-150, you may have 25 controllers. All depend on the options, your ADAS options. So it's going to go in there and pull all that data and let you know that you have codes. And the reason why you have to do this is if you do a calibration and you did not perform that, and there is a code in there and you don't know, you may find out too late. You know, you find out after the fact. So when you find this code after the fact, you don't know if the code was there before you started or if the code occurred after you did the procedure. So you got to start with a clean slate. This has been standard operating procedure for Volkswagen products since 2003, if I recall correctly. All right, so this one here has a vehicle stability system malfunction. So we have to go and fix that. Here's an example of in-shop static calibration. This is a Volkswagen setup, and you can see the rig in front there of the vehicle, and there's a target board, and on that rig, you'll see on the right-hand side, there's an additional camera that's mounted there. So that camera actually helps that individual position that jig on the thrust line. That is the OEM procedure. And we are OEM compliant. We will follow that OEM procedure to make sure that you do the best possible job. We talked about the Ford. We saw that. I like those targets. So how will this affect the wheel alignment business? It does affect the dynamics a little bit. So instead of calling wheel alignment, now it's more vehicle dynamics. Your traction control, your anti-lock brakes, your electronic stability control, lane departure, cruise control, all alter the behavior of that vehicle. And in some cases, they may alter the behavior, but the customer will come in and say, my car is pulling. And actually the car has been aligned incorrectly. The steering angle sensor and torque sensors have different value, and the car is actually being steered by the power steering, realigning the sensors. So in the old days, you'd bring a vehicle in and you would lock that steering wheel with a steering wheel holders that didn't move. You can't do that today because of the sensors on the steering column. That's probably a different alignment deal. Pull and drift compensation. So vehicles that are equipped with electromechanical power steering, the majority of them will have some strategy built in the host controller that will enable that vehicle to compensate for pulls, drifts, roll crowns, and crosswinds. This is to improve the vehicle owner's experience, so he doesn't get that pull. So if your alignment business is less than it was, you may want to start connecting to those vehicles and investigating these computers, because you'll find this information here. Pull compensation enable or disable, short-term pull compensation. So it's like the fuel trim for fuel injectors, right? So if you're driving this, Ford F-150 and the pull compensation is enabled, the system is masking a pull on that car, on that vehicle. You would never feel it, but the report is given to you. The feedback comes through the scan tool. So doing a road test, connect the scan tool. Do a pre-scan. On a pre-scan, you may have codes that will say short-term pull compensation 10 pounds. That's an indication that there's something wrong with that vehicle and the customer doesn't know about it, does not feel it. So then you go drive the vehicle, and if it says pull compensation enabled, you have confirmation that there is a problem. The next step is to disable the power steering. If you want to prove it to the customer, you can fuse out and drive the vehicle with no power steering, and it'll start pulling, because now there's no compensation. Torque steer compensation, same thing. So those electric power steering vehicles are much smarter than an hydraulic power steering vehicle. Right? So in this case, you would have to check the tires, the brakes, the air pressure, the back bushings, the alignment, perform a thorough inspection. And you may even have a code, the DTC 1023, which means that the system, the compensation system, cannot compensate anymore because the pull is too severe. And when you look at the data inside the computer, you'll find things like full compensation value, final pull compensation value, pull compensation enabled status. So the vehicle's not running, not moving, the status will be disabled. Your steering wheel angle, long-term pull compensation, short-term pull compensation. Those are pieces of information that we need to know before we start working on that vehicle. There lies the reason why it's so critical to scan the computers. You do a complete scan, then you go into the EP or electromechanical power steering computer, and you interrogate that computer and pull that data out. Because if you ask the customer, you may say, oh, nothing wrong with the vehicle. And also you have to remove the non-essential loads for the vehicle, check and adjust the fuel level. You know, my experience, it's critical. Windshield washer fluids, you want to make sure the antifreeze is okay, the engine and transmission fluids, all the fluids are okay. Ensure the spare tire and tools are in position, proper location, because all of those will change the ride height a little bit. And if you start stacking all of these together, you may get a big ride height check. And the ride height is critical because the camera height is based on the ride height of that vehicle. In the past, when we did alignment inspection, sometimes we'd measure ride height, and if it wasn't right, we just continued on anyway, right? It wasn't critical. But today, it's a little bit more critical because of all these other components that depend on that position of the vehicle. And the vehicle's been homologated like that. So when they release it from the factory, that manufacturer knows everything about that vehicle, how everything should be set, and that's how it should remain, right? And finally, some alignment machines like the John V. and Hoffman alignment machines will actually measure the tire diameter. And this is critical because the wheel speed sensors send information to several host controllers or is shared by several host controllers. So if you have different tire diameters, you will have different wheel speeds. And for example, worst case scenario, Subaru WRX, fully engaged all-wheel drive vehicle. If the customer is driving that car and it's got like 36,000 miles, and he has a catastrophic failure on one tire, blows it and only replace once, he's going to be repairing the transfer clutch between the front and rear within the next 90 days. So on those types of vehicles, you just can't change one tire. You have to change two. At least the minimum is two on the same axle. The manufacturer recommends all four because now they have different diameters, different speed information, and these are always engaged, or like road magnets. So that clutch will slip and it overheats and it destroy the clutch. So we've heard that from one of our clients that normally when that happens, it's about a $3,800 repair minimum. So this is some information you get from the alignment machine. And there's other information you can get also, like the wheelbase, the track width, the cross dimension, the offset of the axles. So if you're blueprinting a vehicle, not a bad idea to do that. It only takes about a minute to get that data. And you can see here, there's a message. So the left front wheel radius is smaller than the right. So the condition may cause a pull or a camber error in the tire wear. So if it's causing a pull and the electromechanical power steering kicks in and masks that pull, sure, you're going to get tire wear. I always get that. You're going to get tire wear on. Yeah, but the tire wear doesn't show up immediately. The pull does. The pull shows up immediately. The tire wear, well, the tires wore in 36,381 miles instead of 44,000. Okay, there are other, there are other considerations that would cause the tires to wear faster. So this takes me to the end of my presentation here. I just want to recap how important it is to connect to the vehicle, interrogate the vehicle, understand the systems, how they work, understand the space, the environment, and what is required to do the job right the first time. Because I think you only get paid once, right? I hear this a lot on windshields. So I always recommend to use OEM windshields, and some people say, well, no, we use aftermarket. We haven't had a problem. Well, but when you do have a problem, what happens? And the question is, well, do you take the aftermarket windshield off and you put an OEM, but do you get paid twice is the big question. So you have to follow the OEM information to be compliant with the OEM just to cover yourself. So this concludes my presentation. I want to thank you so much. Thank all the participants for staying on. And Jason, are there any questions that we need to handle right now before we leave?
Yeah, we got a couple. What was the app, the calibration app that you shared? What was it? Can you give us the name of that app again?
Can you put it back up there? There we go. Easy ADAS or Easy ADAS. I'm not sure about the iPhone. I don't think there's an iPhone in the at the Play Store or the Google Play or the App Store. It's just Easy ADAS.
Okay.
So when you download the app, it's going to ask you for a registration number, and you'll have information on how to get that.
Okay. And Terry has a question too. Terry, you should be able to take yourself off of mute now and ask, or you can type it in the chat as well. So if you want to go ahead and unmute yourself there, Terry. Doesn't seem to be working. You want to try to type? Are you there now, Terry? Oh, there we go. Go ahead, Terry. All right, we're not hearing Terry. Type a question.
Okay, I've got it. I've got his questions here. The question is, what scan tool do you recommend? We went away there, but it was a question about the scan tool. So I don't want to sound biased, because Snap-on, but the Snap-on scan tool is highly supported. Other scan tools may not be as highly supported. So for example, I don't want to name any names, but there are several good ones out there. There are some that claim If you hear this claim, we have 100% coverage, the next questions out of your mouth to that individual should be, show me the Tesla coverage. And he won't have it. Because Tesla's different. You got to go through the network to get to the vehicle. Completely different. So no one really has 100% coverage. I have to admit, the Snap-on scan tool, we're kind of a little bit behind. We're not as fast as we would have liked to be. But everything we cover works.
Terry, one thing that I often, when people ask me about scan tools and what to look for, I think you really need to take a look at the vehicles you're working on, understand exactly what you want to do, what you don't want to do, what are you going to use, what are you going to do internally, what are you going to, sublet, bring to the dealerships, et cetera. So you really need to kind of look at the vehicles you're going to be working on and really determine what exactly it is that you want to be able to do on it. That's going to really inform your direction on it. So there's not an easy answer to that question. We've got a couple more coming in here, Ron. Let's see here. Is there some sort of subscription or per vehicle charge for the different targets that you need for different vehicles?
So the Easy ADAS system comes in two different flavors. There's the basic kit, and then there's the deluxe kit. So obviously in this environment, we are going to have to update targets regularly because the manufacturers, they do come out with new targets. But the deluxe kit covers probably around 94% of all radars and cameras. Blind spot and AVI is another 44 targets and stands and all kinds of accoutrements that we're looking at trying to minimize the target numbers and the stand numbers. So probably around June, we'll have additional information on, or additional components for blind spot and also for AVMs.
Okay. And then there are a couple questions related to kind of updates. What's your update process for the software and hardware itself?
So we update over the air, and we update 2 times a year.
Okay.
And eventually that is moving to, that's obviously we're forced to change that. So I think we're going to go like our Mitchell or Shopkey subscription, where it updates, just updates, right? I mean, you buy the subscription and it just continually updates itself. You don't have to wait for an update.
And how far back does it go for, I guess that might be your own calibrations of the question. How far back?
That's a good question. I guess it depends on the vehicle. Volkswagen, I know we cover all the way back to 2003.
Okay. Cool. I think that's about all the questions. Anybody else? Last call on either the chat or Q&A? I think we've got most of them. Okay, what about recent vehicles? What are some of the newer vehicles that you've got on there? And again, that's why I was kind of going with the update question. So that's going to vary as well, I would imagine.
Right now we go up to 2018. Because you got to remember our customers are normally the general repair shops. And those general repair shops do not work on current model year cars. So we had to have a paradigm shift in our philosophies to step it up. By June of this year, we'll have current model year information, because for the collision, there's 3 industries we're dealing with. One is collision, yep. And collision requires current model year information and all the targets. The glass industry, they require current model year information, but they only want front camera targets. They don't want the radars or rears or AVMs. They're not interested in that. And then the general repair, well, then you have the specialists, you have the Asians, the Germans, the domestics. I want to do pickup trucks. There's a mix and match. So we're looking at the configuration or the product offering to reconfigure it to better meet those needs, those customers' needs.
And one more question. Do you have a list of vehicles that need the side mat targets?
I can pull a list. I don't have a formal list, but I have access to the data and I can pull a list.
Yeah, and again, there's gonna be different targets. So again, as we saw in the presentation, there's gonna be different targets. So a master list wouldn't necessarily do a whole lot of good. You really need to kind of take it on a case-by-case basis. So as each vehicle comes in, with a 360-degree camera that you need to calibrate. You know, that's going to be the best source for information on exactly which targets and which locations, et cetera, because they're not going to be the same. So
Correct.
I think that's a little bit more important. Just refer back to the OIM information. So awesome. Well, with that, I want to thank you for your time, everybody for their time. Really appreciate it, Ron, and Snap-on team for making this possible. Some fantastic content. And we are back. I'm going to pull up real quick here if I can find my schedule. I keep burying it. We'll be back this afternoon. If I can pull it up here, come on. Just one more presentation this afternoon. Get my stuff queued up here. I had some computer issues this morning, so I'm off my game. We've got Mickey Woods back this afternoon taking marketing to the next level. So join us for that. Mickey's going to give us some more good information on promoting our shops and our businesses. So until then, I hope everybody has a great rest of your morning and early afternoon. We'll talk to you later. Bye-bye. Thanks.